Okay, so I saw this problem on the internet. I do recommend you watch this guy's video. He does it differently than me. These are typical questions. When I say typical questions that typically appear on exams where they're testing a student's skill at understanding the problem. So this symbol over here, I can't say it's universally used, but most calculus books actually use this symbol over here for the greatest integer function. There's a footnote there, 114. If you read that, and it says computers often refer to this as the floor function, all right? They state the greatest integer, and this is a typical symbol that's used as well, by the way. This makes more sense to me, because I'm looking at this thing, they got the little hat mark there below the x, the floor of x, all right? So it says not larger than x, all right? So the greatest integer, not larger than x, all right? The C languages, and this is probably true in Python too, I can't remember. Yeah, I think it is true in Python, that's the floor, all right? Now, the way he did it is different than the way I did it. The way I was looking at it, I'm looking at this thing as an integer problem, all right? And why do I know it's an integer problem? These things are integers over here, all right? Now, what I mean by that, the floor of those numbers are integers. Then the question becomes is, when do they change their values? So the first thing I looked at, let me get my eraser out, is I looked at where the 3x was jumping. And the 3x is going to be jumping, right? So at 0 up to 1/3, and again, we're talking about the floor of 3x now. This is going to be 0. And then if I did 1/3, now 3 times 1/3 is 1, up to 2/3, that's going to produce a 1, all right? And then if I want the next one's going to be 2/3 to 3/3, that's going to be 2. And let me write down the other one for you, by the way, the floor of x now. For this interval over here, I'm going to do the same thing. This is going to be 0. The next one, it's still going to be 0. The next one, it's still going to be 0. All right? Let's go to the next one now. It's going to be 3/3 up to 4/3. This is going to be 3. All right? And why is that? When you're looking at something, it's, like if I did, 3 times 1 is 3, the floor of 3 is 3, and if I don't go past 4/3, it's going to remain to be 3. And then this one over here is going to go to 1. Now, someone says, why are you doing this? Well, the reason I'm doing this, I'm realizing I have to add these things together, and I'm nowhere near what they want me to be, which is 6. Now, granted, that was a really big number. I don't think this would be a good technique, by the way. But if I look at this one over that would be a sum of 1. That would be a sum of 2. Well, you know what? I'm getting closer. All right, I'm getting closer. All right? So let's go to the next one. That's going to be 4/3 to 5/3. What's that going to give me? That's going to give me 4. What's this one going to give me? 1. Let's go to the next one. That's going to be 5/3 and 6/3. What does that give me? 5. What would this give me? 1. I want to point out, you're seeing these in groups of 3s, by the way. You're seeing these things jump by 1 each time. I think I'm there. I got the 5 and 1. What's 5 and 1? That's going to give me 6. All right? 5 and 1 gives me 6. Is that what I want? That's what I wanted. Now, again, someone says, well, what if I go to the next one? What's the next one going to be? That's going to be 6/3 and 5/3. And, whoops, sorry about that. That's an open interval. That's going to give you 6. What's this one going to give you? It's going to give you 2 now. You're out of range, by the way. So this is the only one that's going to give it. So what's the solution for this over here? X is going to be between 5/3 and 6/3. Let me make it look neater. So X goes from 5/3 up to 6/3. What's 6/3 though? Which is 2, right? That's an infinite number of solutions, by the way, and that's what they're asking for. That's what you're going to give them. Again, I want to point out, if you look at this guy's solution over here, he does something different than I'm doing. Here's the deal, though. You probably should look at a variety of ways people do things, and then try to decide which is best for you. All right? Now, granted, it's nice to know other ways to do things. It really is. Because I got to be honest with you, if this weren't 6, like that there were 6,000, I don't think I'd want to go through all that work of marching up to it. But getting to 6 wasn't so bad, by the way. So it's nice to have alternatives, by the way. And it's good to look at other people solve problems like this. Thank you so much for listening.